Hello and welcome to tutorial 8, the final tutorial of the Platemaker Wizard. So you know the drill, let's get into it. So first of all we go add-ins, Platemaker, we want to go help demonstration workbook, we need to view the instruction manual, and we go down to the table of contents and we want tutorial 8. A robot 96 wellhead transfer to a 384 well plate example. So this is a very specific tutorial for people who have robotic 96 channel heads on their robots that can deal with 96 well plates in one single addition. And most of you may not be in that situation, but I still strongly recommend that you do this tutorial anyway, because it also gives you extra information and understanding of all the stuff we've done so far, and it's a good summary of some of the work that we've done. It sort of puts into practice some of the different techniques that can be used in the different menu settings of the Platemaker Wizard. Okay, so let's get to it. So first of all, you need to read figure 132. But what we're going to do now is we're going to switch over and I'm going to do an animated version of figure 132 just so you can see how a 96 well channel robotic head can add 4 samples to a 384 well plate. So let me show you what I mean. So the 96 channel head is similar to an 8 channel pipettor. So remember, the 8 channel pipettor accesses every second well of the 384 well plate. In the same way, in columns, the 96 well channel also only accesses every second well of the 384 well plate, but also it's doing the same in rows. So because it's two-dimensional, it's accessing every second column of the 384 well plate. You can see the 96 channels are plating exactly a quarter of the 384 plate, and that is the first quadrant. If we were plating the exact same sample 4 times, then you can see how this would work. So it would simply strike here, then the next plating would be here in red, the third plating would be here in green, and the last plating would be here in purple. So this effectively means that if each individual number represents a different sample, you can see that each sample has been plated 4 times, as shown by the yellow square. So that is pretty much figure 132. So read that and you should understand how a 96 well channel pipettor will access a 384 well plate. So what we're going to do is we're going to now replicate this type of experiment using the Platemaker Wizard. So in order to do that, the first thing we need to do is we need to open up the chemotherapy master workbook. So let's do that. So we're going to close this one. We're going to open the file manager, documents. We need the Platemaker Wizard data shortcut. We need tutorial and its chemotherapy master plates. And now we're ready to begin our exercise. So returning to our instruction manual, we go add-ins, create new data entry workbook. We're going to skip over page 1 altogether. On page 2 we want compound and dose. And in compound, this is a text variable. We're going to add the data from the external worksheet. And we want to select 4 columns. We're going to use the collapse 2 columns. And the reason we're going to use collapse 2 is also explained in detail on the top of page 197. But just to remind you that we have to think about the physicality of the experiment when we're doing this. So this is a simple 8-channel transfer of the drugs to a column of a 96 well plate. And you can see that we're going to plate a dose response curve of 6. So you need to just read about this to work out how we got to 2. I'm not going to explain it here actually because I've been through this before, but if you read this you should understand why it's collapsed 2. Okay, and even if you get it wrong in your real examples, what would happen is as you create your plate maps you would see that there's a problem and you just keep working with the Platemaker Wizard until you get the layout that you need. So That's it. Okay, so let's now collapse 2. So we go OK, and our data goes in. We have our 32. And we want a simple 6-point dose response curve with 0 nanomolar at the end and 5 doses. And this time we're going to go semi-log. And we want semi-log increasing. We want it increasing to the center. And we're going to start with the lowest value of 1. But you'll notice that in your instructions, it tells you to type 1.00. And the reason it does this is to demonstrate, you can see this hint down here, how this section of the independent value generator works. So in fact, you can control the precision of data that is returned to the box by whatever the start value is. So if you just type 1 and 5 and you push the end value, you'll just get the semi-log as whole numbers. However, if I type 1.00 and I return, you can see that now I have it to 2 decimal places. So you can also control the precision of the data that the independent value generator is returning to the list box. So that's just a little extra function of the independent value generator inside the Platemaker Wizard. So we have our first 5 points. Our 6th point is going to be our 0 dose. So that's just 0 nanomolar. So we add that. And that's it. It's that easy. So we're just going to have a very straight 6-point dose response curve. We've got our 32 compounds. It's in combinatorial. We simply click next. Now the dependent variable we're just going to have is going to be cell death. So we just enter that. It's percentage. We click add and next. We're not going to do anything with equations. We click next, nice and simple, and we're just going to click preview. And here we have a nice and very simple 96 well, 6 dose, 32 compound experiment, which is shown in figure 134 here. Now this experiment is probably one of the most basic experiments that probably a lot of experimentalists do, and it's not sophisticated in that if you actually look at the flat data table, you will see that each 0 dose is associated with a different drug. So it's almost like the 0 dose for each drug has been specified. But of course we know that 0 dose is not really a drug at all. It should really be DMSO. But this will still work, especially if you're doing multiple experiments. You can, if you want, just have a 0 dose for each drug, and then when you mean the 3 experiments, you'll get the same mean anyway, because even if you are meaning the DMSO, when you mean across the 3 drugs, the variance in the DMSO 0 dose controls will disappear anyway, because you'll just be taking the average. So this will still work, and often this is how experiments would do this. So there's nothing really wrong with this design. It's just very, very simple, and you can use it. And if you're just doing a single experiment, well, you only have a single non-variable for each compound dose, so you might as well just have a single reading for 0 and you'll get your dose response curve without any variance, so that's fine. So there's nothing wrong with this design, but we're going to make it slightly more sophisticated. And the first thing we're going to do is we're going to correctly label the 0 dose so it is saying DMSO rather than each drug at 0. And we also are going to introduce a positive control. And we're going to do this though using the linear linking and modifying the flat data table when it has been partially built. So let's do that exercise. So we click reject. And we go back now to page 2 of the wizard. And on compound, we now tick pause build, and we go next, and we click preview. And now what will happen is we will get our partially built flat data table here. And what we're going to do is we're just simply going to now click save changes without doing anything at the moment and finish editing, so that it linearizes. So now we have our data in the linear format. And this time what we're going to do is we're going to go through to the bottom of the first dose, and we're going to delete all these second things. So remember, that is the first 6. We're going to delete everything beyond that. So we do that. And now what we're going to do is we're going to introduce our positive control. Now our positive control, as you know, the ones that we're using is standard benzoathenium chloride at 100 micromolar. So we're going to add that. So we're just going to type 100, and fortuitously for us it is in micromolar, which you'll see is useful because we can use that dimension to select it in our partially built flat data table, as you'll see in a minute. So let's do that. So we select micromolar and we add it. And now, if you remember, we're trying to sort of replicate this movement where we have it going up to the middle in dose response, then we have the two controls, and then down, descending dose response. Now you want a semi-log descending down. So therefore, we need to start again at 100 nanomolar and go back down to 1. So it's a now descending 5-point semi-log dose response curve. So let's do that. So it's semi-log decreasing, so we want 100. But remember, we also want to specify 2 decimal places, so it's going to be 0.00. We want 5 doses, and we click return. And now we have our pattern of 12, which covers the whole row of the 96 volt plate. Now we're starting on the left of the plate. We have 1 to 100, that's the 5-point dose response curve. Then we have the 0 dose control in the center of the plate, that's in column 6. Then we have the 100 micromolar in column 7, and then we have the descent 100 down to 1 going to column 12. And that's the first row of the 96 well plate in linear links, so this will all work. But the final thing we want to do is we also want to change the labels of this to DMSO and the labels of this to benzoathenium chloride, these 2 center ones. So the way we do that is we go back to compound, we select pause build, we click next, we click next, we click next, and we click preview. And now you can see we can start to do this little trick of relabeling these two. So what we're going to do is, remember, the first ones we need to relabel as the 0 nanomolar dose. So we can click on here and we select 0. And now we have all the zeros. This just has to be labeled as DMSO. So we type DMSO, and then we need to copy this to the others. And one way to do it is to simply go Control C, place your cursor on the next row, which is column 20, use the Shift key and place it on the bottom, which is rapamycin, row 188, and then click Control V, and that's all in. We then release this filter, and the next filter we need to select, we can't select 100 because we have both 100 nanomolar and 100 micromolar, but we can select uniquely the positive control by just selecting the dose dimension, which is 100 micromolar. So we do this, and this one has to be benzoathenium chloride, like so. And another way you can copy these is, if you probably know this, but if you move your cursor to the very corner of the cell, you see it changes to that black plus, and then you can just drop it down and it copies it right the way down. So we then say save these changes to menu, we click finish editing, we go next, 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 and preview. And now you can see we have exactly what we want. So we've managed to now create a negative control in the center, which is our DMSO, and our positive control, which is benzoathenium chloride. Now, one final thing I'm going to do is I'm just going to go back to page 1, and I'm going to change this to 3 samples, and I'm going to group them like so. And if you've done everything correctly, you will end up with this map here, which, if we go back to our tutorials, we've worked through all of this, we've worked through all of this, we've worked through all of this, we end up with this map here. Okay, this is grouping samples, we end up with this map here. And if you look at 136, which is here, you will see that this is actually now very, very similar to the plate maps of the demonstration workbook, which comes shipped with the Platemaker Wizard. In fact, the only real difference is this is a 96 well design, whereas this is the 384 well design, and that's explained in figure 136. But you'll notice that we've achieved this layout without resorting to page 3 and using plate controls. We've done it purely by editing the flat data table in partial building. What I'm trying to demonstrate here is there's more than one way to achieve the same objective using the Platemaker Wizard. So this is why it's such a powerful program. Okay, so what we're going to do now is we're going to literally take this 96 well plate and convert it to the 384 well version, but with quadruplicate plating. This is almost replicating virtually what is happening in the Platemaker Wizard is actually what happened in the lab, because in the lab what you would have is you'd probably prepare a master 96 well plate with all the doses laid out like this, and then the robot would come across with the 96 well channel head and pick up all the samples from the 96 well plates and stamp the 4 quadrants of the 384 well plate as shown before. And remember this, okay, so it would go 1, it would pick up the first set, go back to the same plate, stamp it a second time, go back to the same 96 well plate, stamp it a third time, and go back to a 96 well plate and stamp it a fourth time. Or your robot might even just take up the whole lot in one go, if it's a small amount, and just stamp it 4 times. Although, interestingly enough, you'll know that if you do it that way, it's not quite as accurate, even though it's a bit faster, but that's just a bit of robotics for you. Okay, so let's now pretty much replicate the building of the 384 plate on the Platemaker Wizard. So how do we do that? Well, it's very easy. What we're going to do is we first of all push reject, and now we go back to our very first page, and now we're going to change the number of samples to 4, because remember it's quadruplicate plating, because it's a quadrant of the 384 plate. We need to ungroup the samples. We go back to page 6. We now need to change it to a 384 well plate, and now what we need to do is we need to simply change it to 2 columns by 2 rows. Remember, we want that very, very small box of 4, that little tiny 4 box, 2 by 2 little box of subplating. So it's a very small subplating area. Now you notice the use leftover space has appeared, but it's blanked out. And the reason it's blanked out is because a lot of the examples we've given before, the number in the subplating area was not divisible into the total plate dimension. So there was a leftover space. So let me explain what I mean by that. So we have 24 columns. So if I was to select 7, 7 doesn't go into 24. So what would happen is I'd then have a leftover space. But 2 does go into 24. And we have 16 rows, and 2 goes into 16. So because they're both divisible, there is actually no leftover space, because you'll create the exact number of subplating areas without any leftover space. So this is why this option is not selectable. Okay, so we've done that. We now just click Preview. And now if you've done everything correctly, you will get these lovely plate maps here. And you can see that now all our 96 well plate has been converted straight to a 384 plate with the very distinctive quadrant plating. So you can see, just to go back to here, this quadrant here is here. You see the quadrants going there, 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 there. And you can see that now the original 8 controls has been expanded in 4s. So now we have 8 4s are 32 negative controls and 32 positive controls. And this is explained down here. Okay, so now there's an interesting little bit of statistics to think about if you do the experiment this way. So this is explained from here. So you might start to worry, well, hang on a minute. This is 32 negative controls, and this is 32 positive controls. But these are not enumerated individually as 1 to 32. They're only enumerated in the sample numbers as 1 to 4. So will that not cause a problem? And the answer is it usually doesn't, and that's explained here. So what you need to do is you need to read carefully what's going on here, and also particularly look at figure 137, because 137 explains if you're using a pivot table, as long as you don't use an intermediate table where the sample numbers are enumerated, you will always get the correct answer. So if you look at figure 137, panels A, C and D will give you the correct answer. The only one that doesn't work is panel B, and that's using this design where you ask for an intermediate table. And even then, it'll still give you the correct mean, it just won't give you the correct standard error of mean. And the reason it'll give you the correct mean is because of this mathematical expression here. So again, this is extra detail that you can read, and this is really just going into the subtleties of more statistical analysis rather than plate design. So what I'm trying to say, long story short, is this in many situations will be a completely adequate design anyway if you use standard pivot tables. There's only one example where you can come unstuck, and that is where you ask it to calculate before the individual means of the sample repeats. In that situation, the SEM will be incorrect. Okay, so that's that section there. So read figure 137 and you will understand that. Right, so now what we're going to do is we've pretty much created our plate design completely adequately using no controls. And this will work most of the time. But let's now, as a final exercise, instead of doing it this way, let's still keep the quadrant plating, but this time we'll add the controls using page 3 of the wizard, which will be our final exercise of this tutorial. So I'm going to select accept for this because this is our first example of how to do it. And now I'm going to select resume last workbook build. I'm going to click next. And what we're going to do this time is we're going to remove all the controls that are in this point and then replace them with controls generated on page 3. So how do I do that? Well, it's very easy. I'm just going to click pause build. I click next, 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 and preview. And when the flat data build appears, I need to select, if you remember, all the 0 like so, and I need to delete all of these. So I simply select them all. So what I do, I click the first one on 8. I actually click 8, so I select the whole row. And then while holding the shift key, I select 188 again on 188, so it selects the whole row. I then right click and I click delete row and all these disappear. I then undo that filter. I want the benzothenium chloride, so again I simply select benzothenium chloride. I select the top one, hold the shift key, select the bottom one, right click and select delete row, so all these go, and then I want to save those changes back to the menu and I click finish editing. And now it is simply taken out all those controls, so they're now missing. Now I need to add them back using page 3 of the wizard, so let's click next. So on page 3 of the wizard, I'm going to now use plate controls. I need to inject the data into compound and dose. I can use this plate first, but I want it on every single plate. And now I enter my 2 controls, so it's DMSO, it's 0, and it's nanomolar. And now we know the correct number is 32, okay, because it's 8 by 4, which is 32 samples. So we add, and our positive control is benzothenium chloride. It's 100, and it's micromolar, and I click add. Now also, the one advantage of using controls is you can then also ask the Platemaker Wizard to calculate the average, and if you calculate the average you can then use that in your formula for cell death. So let's do that. So I'm going to click on DMSO and I'm going to tell it to calculate the average. So now it's going to calculate the average. I click next, and now you can see I have my average and my cell death. So now I can build my cell death normalize formula, which I can do, and I can do this as I've done before in other tutorials, but hey, let's cheat a bit. If I go down here, so we're still following this, there's the formula there. I'm just going to actually paste it in because it'll just work, because it's just text, so let's just paste it straight in, like so. Save myself. Oh, I need to give it the name, so it's cell death normalized, and it's percentage, and I click add, and it goes in nicely. Okay, and now I click next. I'm on page 5 of the wizard. Now you can see I have these new section, remember, where I can control where the control is going to lay out. So I definitely want the controls in a separate area, and they obviously need to be in separate columns because they're in columns. So I say controls in separate columns. The offset, remember, I want them centered, so the offset has to be 10. You can see that by the map. Okay, so we're offsetting by 10. So I push 10 there. And the control layout direction is also by columns. So I select by columns. And now if I click preview, if you've done everything correctly, you should end up with this plate map, which is shown here. And this is figure 139. So there it is. So again, if you look at this, although the controls do not follow the quadrant pattern, it is actually correct because obviously 32 controls, you can see they're still laid out exactly the same, but now we do have the correct labeling of the control. So while we only have 4 repeats for each experimental sample, we have all 32 controls specified. You can see here sample number 1 to 32 for the controls. The other advantage is we also now, as you can see, have our cell death normalized formula here, which of course is based on the fact that down here we've calculated the DMSO average. So it's all working very nicely. So we can select accept for that one. And that is pretty much the tutorial. So in summary, in this tutorial, we've learned how to use subplating error on page 5 to replicate the 96 well robot pipettor, producing a transfer from a 96 well plate to a 384 well plate. And all it goes to say is if you've worked through all 9 tutorials, congratulations! You've completed the complete training of the Platemaker Wizard, and so now you should be an expert in using this program. So I do plan to make a few more videos on other aspects of the wizard. So for example, all the utilities that the wizard provides. Again, if you want to know about these, you can see them here. With program options, you have all these different utilities. And if I was to select one of these utilities, you can see some of them I already have switched on. If I select one of these utilities, everything has a help menu. You can read about what each utility does. Okay, so that's the end of the tutorials up to now. I hope you enjoyed this tutorial. If you did, please do click the like key and also consider subscribing to this channel so that more scientists get to hear about the Platemaker Wizard. So it just leaves me to say one final time, I wish you all the best with all your experiments. Bye.